Welcome to another chapter in my bike engine car. It's powered by a Suzuki RF 900 engine, which is a baby GSXR engine. It's about as small as a car can be. The engine, as you can see, is to the right of the driver to make it even more compact. I have about 130 horsepower in a car which is weighing in at about 370 kilograms. The car is built from mostly scrap components that I've had lying around in my spare parts bin, and as a result there are a lot of unique solutions to complex problems. Attention now turns to plumbing, and by plumbing I mean coolant lines, brake lines, fuel lines, electrical layout. I want to get these things in place even at this early stage, because I'll have to make a myriad of brackets, and also the lines have to run to avoid things like feet, hot exhaust pipes, things that bend and hinge. The motorcycle's throttle cables are quite short, and I've got some tricky fittings where they go to the throttle on the hand and the carbs on the top of the engine. So they're not going to work on a car where the throttle is down at the feet and maybe 1.5 meters away from the engine itself. The answer for the cable has been a brake cable from a push bike, which is the same diameter cable running in a Teflon liner, and which actually pushes into the fitting for the throttle on the bike carbs. It's a back brake cable from a bike which is 1.5 meters long, which means that it's long enough to run all the way down to the front of the car, where I can fit it to the accelerator pedal. This has required a lot of fiddly home bodgy machining. So at the accelerator end of the cable there is a cable guide, which is basically an 8mm bolt with a hole through the center of it, big enough for the cable to slip into, and at the end a smaller hole for the cable itself to come out of. This can fit then through the frame of the car low enough and guide the cable up to the accelerator pedal. The accelerator pedal itself has provided its own machining challenges. It's basically a piece of 50 by 25 by 3 aluminium channel. It has bearings in the end so that it rotates freely, and a crush tube to keep the bearings spaced when it's all bolted in place. I've had to machine up a sector from a piece of aluminium so that the cable comes in there and is held down by this pinch bolt with a hole in it, and as the throttle cable rotates, the cable is pulled around the sector so that it can draw the throttle cable out and operate the throttle slides on the engine. This bolt here is to mount a return spring. I need a spring at both ends for safety reasons. There's one spring provided by the carburetor, and I'll have an extension spring on this end to pull the cable back. Motorsport regulations require an OEM tank. This is a OEM Honda industrial tank of about 6 litres. I'll fit a rollover valve, a rollover and anti-surge, anti-slop breather valve, which will be plumbed out to a catch can. The fuel system is relatively easy because the RF 900 uses an electric fuel pump. So I just run it from the standard fuel cock, which I can access from the rear of the vehicle, through the pump, and then through a fuel hose up to the engine. Piece of cake. The clutch line is the original Suzuki clutch line, rotated 180 degrees to run under the engine. And there's just enough length in the clutch line to emerge and be fixed to my clutch master without interfering with the driver's feet. The clutch master, if you'll recall, is in fact the old rear brake master repurposed. The feed to the clutch reservoir goes up to the front bulkhead where it meets the master reservoir there. The brake hard line runs down the length of the car and connects with this brake hose, which in turn connects on to the rear master cylinder. The front brakes are brake hoses from a clearance sale at a local motor parts shop. God knows what they're off. They cost $4. There are also two short hard brake lines at the front from the front master, which is 1/8 NPT for my sins, into the M10 bubble flare union, and then out either side to the brake hoses on the wheels. The brake lines are in. The main line down the length of the car may be a bit snaky at the front here, but at least I've got plenty of extra if I have to remake the lines or run them in different directions. The hard lines at the front had to be twisted and shaped to worm their way through the various suspension and steering components to reach the hose ends. I have to clip the brake lines in place and also put mounts on the chassis for the hose ends. That's not a particularly difficult task. I'll save that for another day. The bike's electrics are in this mystery box. Hopefully I've labelled everything so that I can get it back together again. Whenever I do motor vehicle wiring and look at it for the first time, I almost want to go inside and have a wee cry. In this case, most of the labelling is right, but of course 10% of the labelling is missing. So I've got to go up and examine the wiring diagrams. Okay, I've got a bit more comfort in the wiring now. I've checked the wiring diagram. I've taken off some of the loom tape so that I can just track the wiring and check my connections. And I've laid out the wires geographically. Some of the wires need to be extended, and I need to find good homes for things like the coil. But if I put it together carefully and only cut and join one wire at a time where I have to, I should replicate the wiring on the motorbike. And the last time that was used, it worked. I've removed stuff I don't need for a motorsport car. I've removed the headlights and indicators and horn. That's the basic layout of the electric sorted. The overall key thing is the position of the coils, because they're fixed by the length and direction of the HT wires, and I really don't want to fiddle about with those, which means that the coils are mounted in front of the engine, and I'll just have to put a little heat shield in there to stop them being cooked by the headers and also to weatherproof them. Thereafter, everything else kind of falls where it falls. There's plenty of wire to run up to the dash. The fan wires are more or less in the right place. The igniter I can put up here and shelter from the weather with a suitable cover. Then we come down to the fuse, and the battery will sit in here. You can see most of the battery leads and earths are terminating in this area. There'll be one set of wires running to the back for the rain light. I'll have to extend the plug for the fuel pump because the fuel pump currently resides over there. So overall, less work than I expected. The battery sits low on the floor, and then that determined where other things go, such as the relay control circuitry, the heavyweight wiring, and ultimately, based on the length of the wire runs, things like the ignition igniter, fuse box, and other niceties. Everything is together on the loom. I've cut off the stuff that I don't need. Tried to minimise the splices, although a few were necessary to get cables to the right place. I'm now going to test voltages here and there around the engine and tidy up some of the wiring, although I won't cover the wiring just in case there are any last minute changes to circuitry. All right, we have volts. All I have to do now is clamp that earth lead to the chassis and the vehicle is live. It's a nervous moment when you hook something to power for the first time. Here goes nothing. No smoke. That's a good sign. Okay, let's turn the key and see if good signs continue. Oh, that's very promising. We are live. There are very few circuits to test. I can use the co-opted turn indicator, which now operates the rain lights. Good, that seems to be working quite nicely. I can also test the brake light just by jumpering it. Very good, very good. Do we have a starter? Just my luck, the engine will actually start on what's in the fuel balls. Right, we have go.